Hi, so here we have question 4 of the June 2013 Waec math exam. And it says, in what number base is the addition 465 plus 24 plus 225 equal to 1050? That is to say, in what base will I carry out the addition here and obtain this result? That's simply what the question is asking. Now, if you recall from your lessons, the base we normally work in is base 10. And just as a quick check, let's check to see if base 10 is the actual base that the addition is carried out in. I mean, let's see what we get if we do the addition, carry out the addition in base 10. Using your calculator, you'll get this to be 714. Now, we carried out the addition, this addition, in base 10, I got 714. The question says, ask for the base in which you carry this addition out and get 1050. Clearly, the answer is not base 10. So we have a base that's not base 10. So let's say let the unknown base be x. Now, when working with, so we clearly know that all the numbers here and a different base is not 10. And when working with bases other than 10, in a lot of cases, it's easier to convert all the numbers to base 10 and then carry out whatever operation. It's usually easy to do that. Now, you need to know how to convert to bases. So I'll just demonstrate. I mean, you should review your notes, but I'll just demonstrate using an example of how to do a conversion from a base that's not 10 to base 10. I mean, convert from any base to base 10, let's put it that way. So, convert to base 10. That should be conversion to base 10, but anyway. Just take that. Okay. So let's say we had a number 1205 to base 6, and you require to convert this to base 10. How would you go about this? If you haven't revised your notes, well, I'll try and be as detailed as possible in the limited time I want to make this video, and the limits I have to make this video, sorry. So you write the number out, and I hope you recall you have to realize that this number is made up of digits. So here we have 1, 2, 3, 4 digits. Digit 5, digit 2, digit 0, digit 1. And I mean, this digit is 1. And each of these digits have place values. And if you start with the rightmost digit, you label its place value. So I'm labeling place values now. This is 1. The rightmost digit of any number, regardless of the base, is always 1. But the next place value, and the place value of the next digit has to be the base, and then the next one is the base squared, and the next one is the base cubed. So say I had 1025 to the base x, so x is some unknown base. The place values would be 1 for the rightmost base, the base for the next one, the base squared, and base cubed. So x5 has a place value of 1, 2 has a place value of x, 0 has a place value of x squared, 1 has a place value of, and that's a bad idea, 1 has a place value of x cubed. And the way you convert to base 10 is then you multiply each digit by its place value and add the product. So for this case, you'll have 1 times x cubed, which is x cubed, plus 0 times x squared, which is 0, plus 2 times x, which is 2x, plus 5 times 1, which is 5. So therefore, this number 1025 base x is x cubed plus 2x plus 5 when converted to base 10. This problem I just solved here is in terms of x, which is a known base. Here we have 10256 to the base 125 to base 6. So to convert to base 10, you multiply each digit by its place value. So let's start with 1. 1's place value is 6 to the 3. So we have 1 times 6 to the 3, which is 6 to the 3. 0's place value is 6 squared. I mean, 0 times 6 squared is 0. 2's place value is 6. 2 times 6 is 12. 5's place value is 1. 5 times 1 is 5. So you can simplify it as 6 cubed plus 17. You can find out what's, 6 cubed is 36 times 6. And then you add 17. So you get, use a calculator, 6 cubed plus 17, you get 233. That is to say, if I converted 1025.6 to base 10, I get 233. So that's just a quick revision of converting from some base to base 10. So now what I propose to solve this question is to convert each of these numbers to base 10, carry out the addition, then and then convert 1050 to base 10 and compare. See if the left hand side, then you have an equation saying, you then equate the left hand side to the right hand side, because you want the case where this addition is equal to this in the base. So I guess the first place to start is, the question says 465 base x plus 24 base x plus 225 base x is equal to 1050, not 1050, 1050 x. You don't say 1050, you only pronounce words numbers that way in base 10. That's just a minor thing though. So this is what the question says. It says find this x. I propose that we convert each of these numbers to base 10. So you have the base 10 form of the left hand side, and convert the right hand side also to base 10. And if you have an equation, you have a left hand side and right hand side. If you convert the left hand side to a base and convert the right hand side to the same base, they need to be equal. And if you know that, we can proceed. So using the technique I just showed you above for converting numbers to base 10, this is 465 base x, and I'm going to convert it to base 10. So just going to label the place values. Remember, the first one is m1, then x squared. So I'm going to try and do it quickly to reduce the length of this video. So all I just did was multiply 4 by x squared, 6 by x, 5 by 1, and add them up. That's all I just did now. Doing the same thing for 24, or a similar procedure for 24 base x. Place value is 1x, so you have 2x plus 4 times 1, 4. So that's 4x in base 10, and finally, 225 base x converted to base 10. Place value here is 1, place value here is x, place value here is x squared, and this should give you, you multiply each digit by its place value. So we have 2 times x squared is 2x squared, 2 times x is 2x, 5 times 1 is 5. And finally, the right hand side of the equation, 1050 base x to base 10. Place value for the first digit is 1, place value for the next digit is x, place value for the next digit is x squared, place value for the next digit x cubed. So, 1 times x cubed is x cubed. 0 times x squared is 0. And you keep adding the product. So 5 times x is 5x. 0 times 1 is 0. So we get, so now let me just go back to the original equation. The original equation is this. This is basically what the question tells you. It tells you, I do this addition in base x, and I get this term in base x. And all I've done is convert each term to a base 10 value. So this is converted in base 10 is this. 24x to base 10 is this. 225 to base 10 is this. 1050x to base 10 is this. So now I'm going to rewrite the original equation in base 10 and see if I can find x. So rewriting 465 base x, I get 4x squared plus 6x in base 10. I didn't know what I just said. Rewriting 465 base x to base 10 is this expression here. Rewriting then, so it was 465 plus 24x. So 465, let me just put a bracket around it to avoid confusion. Yo. 24x to base 10, we got obtained this to be 2x plus 4. And it was plus 225x to base 10, we got 2x squared plus 2x plus 5. And that was the left hand side. And the right hand side was, I mean, it's simply what we see here, x cubed plus 5x. So before we proceed any further, we have this long equation. It'll be a good idea to simplify it. So let me just drop the brackets and write all the terms out. So I have 4x squared plus 6x plus 5 plus 2x plus 4 plus 2x squared plus 2x plus 5 equals x cubed plus, to write that clearly, x cubed plus 5x. Now let's simplify by dealing just with the terms that have x with the coefficient, dealing with terms involving x squared. So we have 4x squared and we have 2x squared on the left hand side anyway. Wow, why am I taking so much space? 4x squared plus 2x squared. So I'm just going to cancel that out to show that I've used them. Now let's deal with terms involving only x. 6x, 2x, or rather plus 6x plus 2x and plus 2x. That's plus 6x plus 2x is plus 8x plus then adding that to 2x gives 10x plus 10x. So I'm going to cross them out to show that I've worked with them. Finally, we'll deal with the numbers on the left hand side. Well, not finally, but just with numbers like 5, 4, 5. So 5, so we have plus 5 plus 4 plus 5, that's 9. So 5 plus 4 is 9 plus 5, 9 plus 5 is 14. And for the left hand side we have x cubed plus 5x. We have a 5x term here, we have a 10x term there, so let's bring the x's together, the terms involving x together. Let's subtract 5x from both sides so that we from both sides, so that we can get an equation, a simplified equation. I forgot to simplify that. 4x squared plus 2x squared is 6x squared, and plus 10x. So I'm subtracting 5x from both sides, so I'm, that's the subtraction of 5x on this side. Subtracting 5x from the right hand side, so this cancels out to give 0. And finally, not finally, but we now have, 10x minus 5x is 5x plus 14 equals x cubed. So this is what we have when we simplify the equation. And from this, we need to find what x is. Now, if you just go back to the options, wow, we've done a lot of work. Go back to the options, we'll see that x is not 10. Remember, x is let the unknown, let's call it, I forgot to put that. Let the unknown base be x. X is the unknown base. We have the options, isn't b is probably 9 or 8 or 7. So let's try 9. Let's try, you have to do trial and error. What do I mean by try? Well, we have to go to this final equation we have and note that x is a base, and for the actual base, if you substitute the value, so say 9, 8 or 7, the left hand side should equal the right hand side. So try x equals 9. You should be able to do this quickly with your calculator. I'm replacing x with 9 everywhere I see x in this equation. This is the left hand side, and simplifying this gives 6 into 81 plus 5 times 9 is 45 plus 14, which when added together gives 545. Now the right hand side, let's draw a division here, is x cubed, and we're trying x is 9, so we're saying 9 cubed. 9 cubed is 9 times 9 times 9, that's 79. As you can see, the left hand side result is not equal to the right hand side when x is equal to 9. So let's try another guess for x quickly. X equals 7 was the other option in the question problem, and so we have the left hand side as 6x squared plus 5x plus 14. So plug in x is 7, 7 squared plus 5x, or 5 times 7 plus 14 as the left hand side, and the right hand side is 7 cubed. Let's see what we get. Simplifying this, you get, let's do it, 6 times 49, 6 times 49 plus 5 times 7, so 6 times 49 is 294, plus 5 times 7 is 35, plus 14. We get 343. Now with the right hand side term, 7 cubed, if you do that on your calculator, you see that this is also 343. So therefore, x is 7, and this is your solution. So I've done quite a lot, so I'll just quickly review what I just did. We're given an addition, and we're told that if you carry out this addition in a certain base, you should get 1050 in that same base. Now we tried the addition in base 10, which is what we did here. Let me put it there. We tried the addition in base 10, which is what we did here, and we got 714, which is not 1050. So we're able to deduce that 10 was not a solution. Then I proposed that to make the problem simpler, even though it doesn't look so simple, convert each term to base 10, and I showed you how to do conversion to base 10, which is what we did up to here. So what I then did was rewrite the original equation appropriately. So we know it's not base 10, so each number must have a subscript of the base, and I said let the unknown base be x, which is why this x here is a subscript. It's a subscript. It's a notation for numbers in bases other than 10. And I carried out the conversion from base x to base 10, and we got this for each of the numbers. And then I rewrote the equation, this equation, which is the equation, basically the equation I was given in the question. I rewrote each term in base 10. I wrote the left hand side in base 10 and the right hand side in base 10, and equated them, because I know, and you should know this from your lessons, that when you change the bases in an equation of the left hand side and right hand side, the results should also be equal to each other, which is what we did here. This is 465 base x in base 10. This is 24 base x in base 10. This is 225 base x in base 10, and this is 1050 base x in base 10. And finally, and then what I did was simplify the expression. Just simplified by adding, well, the only operation is addition, so I just simplify and got this final expression. So this is essentially a simplified version of the original equation given, but it's now in base 10, and all I had to do was say, okay, what x value satisfies this equation, because that x value is the true value of the base, because it's the value such that when I carry out the addition on the left hand side, I get the right hand side term, which is what I'm saying, which is what we're saying here. When we carried out the addition in base x, we got 1050 base x, but now everything's been converted to base 10. So when I carry out the addition in base 10, I should get what 1050 is in base 10, but obviously we simplified the expression. We simplified the expression to get this. So anyway, the actual base satisfies this equation, and we did that by trial and error using the options we're given. We tried x equals to 9, we got the left hand side equals to 545, and the right hand side equals to 729, which, and you can tell they're not equal, so therefore 9 wasn't the base, or 9 isn't the base rather. And we tried x equals 7, the left hand side we got 343, right hand side we got 343, therefore x equals 7 is the base. And yeah, that's what it is. If you try the last option, which is x equals 8, if I remember clearly, you will also find out that the left hand side is not equal to the right hand side. And that's it for today. Thank you.